Hello and very good evening to our lecturers, Roger. Today we will present about our group assignment project for ICT 200, which is Cyclopath by Co. First of all, I would like to introduce to our group member. First, we have Roslian Syah bin Rostan, which is me. And after that, we have Khairi Adam Ibrahim. We also have Muhammad Danish Rahimi bin Sudirman. And lastly, we have Syed Shafi'i Aiman bin Habib Ishaq. So here is our table of content. We have company background, current system description, problem statement, objective, business rules, ERD, third normal form relational schema, data dictionary, data implementation, and lastly SQL questions.
Yes, starting off with the organizational chart, we have the managing partner, my father, Sudirman Muhammad Awi, and in the service department, we have Jali Lucas and Maximus Edmund, both are in charge of the bike as the bike technician. And then we have the sales department, Deni Jati, who are in charge of the store and the sales. And for the company background, Cyclopath Bike Co. is established by my father, Sudirman Muhammad Alwi, in 2021 and is located at the Airport Commercial Center. For the current system description, as of now, Cyclopath Bike Co. currently uses a manual system to manage its bike rentals, pricing, and inventory. This system relies heavily on handwritten records, which can lead to delays in processing, errors in calculations, and difficulties in maintaining accurate records of the availability of the bikes and maintenance schedules. As such, the current system is disorganized, making it difficult for staff to share information efficiently and for the company to monitor its operations in real time. As you can see, this is the flowchart for the current system description. Starting off, where the process starts, customer comes to the shop and ask whether or not the service or items they want are available or not. If it's yes, then the customer may check out to the counter and the cashier will inform the bill total to them and proceeding with the customer paying the bill. And then the system will check whether or not there is another customer, and if it's yes, then the process will repeat, and if it's no, and the process will end. And here is the problem statement. Here are some problems that the company faces right now while using the manual system. So firstly, we have the inventory management issues. Issues like poor demand forecasting, supply chain delays, and inefficient inventory tracking, driving customers to competitors and harming the loyalty to the company. Thus, addressing this is vital to improving satisfaction, ensuring products availability, and staying competitive with other companies. And next, we have the challenges in inventory tracking. So, manually managing inventory without an automated system can be both time intensive and prone to mistakes. And staffs might fail to update stock levels accurately after sales or misplace items, creating discrepancies between recorded and actual inventory that is recorded. And lastly, for the last problem, we have difficulty in swiftly updating prices. So in a manual setup, adjusting prices involves significant effort, often requiring changes across physical orders, ordering system, and the pricing list itself.
Okay, now for the objective of the proposed database. Firstly is to implement an inventory management system to track stock levels and predict demand based on historical sales data. Secondly, it is to create an automated stock replenishment, which is to alert for low stock items, ensure timely reordering, prevent stock out of popular items. Next is to design a digital point of site POS system with centralized menu management. Here are the examples of business rules within this system. A customer can purchase many bicycles and accessories, but each purchase is associated with only one customer. The availability of bicycle models and accessories determines whether a purchase can be made. A staff member possesses many bicycle purchases, but each purchase is processed by only one staff member. And a mechanic prepares bicycle for customer after purchase, and the system updates inventory levels accordingly. Next, purchase details are sent to the cashier, who calculates and informs the customer of the bill. Customer pay their bills using card or cash, and payment information is stored for each purchase. If another customer makes a purchase, the process starts again, otherwise the session ends.
So next, let's move on to our ERD. So we have staff table, manager table, accessory table, orders table, payment table, customers table, bicycles table, service table, and lastly inventory table. So this is our third normal form relational schema. So first normal form is the every value is atomic and every attribute has unique character. For example, order ID, payment ID, accessory ID, inventory ID, bicycle ID, service ID, customer ID, staff ID, manager ID in one entity, which is bicycles. So for the second normal form, we separate them using their own table, which is we remove the partial dependency. So for example, we have customers table, manager table, staff table, service table, inventory table, bicycles table, accessories table, and that's all. And lastly, for the third normal form, we actually remove the transitive dependency, which is we make a new table for payment.
Is data dictionary. In this part, we basically tell you about the attribute name, data type, primary key, and also the foreign key for each table. Okay, the first table is manager. In manager table, we have three attributes. The first one is manager ID. Manager ID we use data type varchar. The size is 10, not null, and it is a primary key. The second one is manager name. The data type is varchar, size is 100 and not null. And the last one is contact. Data type is varchar, size is 50 and it's not null. The second table is inventory. In this table have two attributes. The first one is inventory ID. The data type is varchar, size is 10, not null, and primary key. The second one is quantity. The data type is integer, not null, and that is for inventory. The next table is bicycle. In bicycle have four attributes. The first one is bicycle ID. Data type is varchar, size is 10, not null, and it is a primary key. The second one is model. Data type is varchar, size is 100, not null. The third one is bicycle price. The data type is decimal, 10 to 2. The last one is inventory ID, varchar, and it's can be null. It is a foreign key. The reference table is inventory. And next table is accessory. In this table have four attributes, which is the first one is accessory ID. Data type is varchar, size is 10, not null, and it is a primary key. The second one is accessory name. Data type is varchar, size is 100, not null. Third one is accessory price. Data type is decimal, 10 to 2, not null. And the last one is inventory ID. Data type is varchar, and it can be null. It's also a primary foreign key. The reference table is inventory ID. Next table is customer. The attribute in customer is customer ID. Data type is baca, size is 10, not null, and it is primary key. The second one is customer name. Data type is baca, size is 100, not null. That one is customer contact. Data type is baca, size is 15, not null. And the last one is address. Data type is baca, size 200, and it is not null and no foreign key here. Next table is staff. The attribute name is staff ID. Data type baca, size 10, not null, and it is a primary key. Next one is staff name. Data type baca, size 100, not null. The third one is staff contact. Baca, size 50, not null. And the last one is foreign key, which is manager ID. Size and data type is 10 and baca. It can be null. And the reference table is from manager. Next table is service. The attribute is service ID. Data type is baca, size 10, not null, and it is a primary key. The second one is service name, baca and 100, size and also not null. The last one is cost. Data type is decimal, 10 to 2, and it is not null. Next table is order. The attribute is order ID. Data type baca, size 10, not null, and it is a primary key. Next is order date. Data type is date, not null, and in this table have 5 foreign key. The first one is customer ID, baca, it can be null, foreign key, and the reference table is customer. Second one is staff ID. Data type is baca, size is 10, it can be null, and it's from table staff. The third one is bicycle ID. Baca, size 10, it can be null, it's from bicycle table. And next one is service ID. Baca 10, size 10, it can be null, it from table service. And the last one is accessory ID. Data type is baca, size is 10, it can be null, and it's from table accessory. And for the last table is payment table, and the attribute is payment ID. Data type is baca, size is 10, not null, and it is a primary key. Next one is order ID. Data type is baca, size is 10, it can be null, and it is a foreign key. Reference table is from orders table. Next is customer ID. Data type is baca, size is 10, it can be null, foreign key. The attribute is from customer table. Next one is amount. Data type is decimal, 10 to 2, not null, and the last one is payment date. Data type is date, and it not null. Okay, the next part is data definition language. So basically in this part is show the SQL to make a database and table for the database. So the first one is make a database. So the SQL is create database Cyclopath by Co as our database name. Use Cyclopath by Co. Second one is for the manager table. The SQL is create table manager and put manager ID, manager name, and contact. This is same like a manager table. Just put the SQL create table, inventory, put inventory ID, the data type, size, and quantity, data type, and for the bicycle table, the SQL is create table, bicycle ID, model, bicycle price, inventory ID, and the foreign key. We have to put foreign key, the attribute for the foreign key, reference, and the reference table for the attribute of a foreign key. Okay, for the accessory table, this is just the same like physical table. Create table, accessory for the table name, accessory ID, accessory name, accessory price, inventory ID. For the foreign key, just the same like physical ID. And for the customer table, there is no foreign key here, so it is just the same like manager table. We just put customer create table, customer as a table name, customer ID, customer name, customer contact, and address. In this table also the same as a physical table. We just put create table, staff, and put all the information of staff, just staff ID, staff name, staff contact, the manager ID for the foreign key, and the reference is from manager table. And for the service table, it's the same like manager table, which is no foreign key. So we just put the table name, which is service, and the information of the service, which is service ID, service name, and the cost with decimal to the 10 to 2. Next one is for the orders table. So we just put a table order, all the information of the order, ID, order date, customer ID, staff ID, physical ID, service ID, accessory ID is for the foreign key, which is the reference is from customer, staff, physical, service, and accessory table. For the last table is payment table. Just the SQL is create table, payment, the name of the table, information of the payment table, which is payment ID, the primary key, order ID, customer ID, amount, payment date, and the foreign key is order ID. The reference is from order table, and customer ID reference is from customer table. Next part is for data manipulation language. So basically in this part we just call all the information in certain table. For example, the first table is accessory. So the SQL is select from accessory, and the output will show all the information in the table. The next table is bicycle output. Have only 3 model, which is road bike, mountain bike, folding bike, and also show the price and the ID, inventory ID, and also physical ID. Next one is manager table. So the SQL is select from manager, and the manager is only one, which is Sudirman Muhammad only. And the next one is inventory table. SQL is the same. Select from and just change the name of table, which is inventory, and the output will be shown all the information in the table. Table is order. So the SQL is select from and the name of the table order, and the output will be shown all the information in the order. So for example, like the line 1 and 2. Line 1 is order ID 1, that is first January, ID is class 1, and so on. Next one is payment table. So the SQL is select from and the name of table payment, and the output will be show all the information in the table. One is service table. SQL select from name of table service, and the output will show all the service in our project. And the last table is staff. SQL is select from the name of table staff, and output will be show all the information of staff, which is we only have 3 staff, and the staff is Charlie Lucas, Maximus, Edmund, and Danny Jati. And I think that's all from me.
So here is our 5 SQL question. Question 1. List all orders where the amount paid is greater than 2,000 and sort them by order date in ascending order. So first, we do select order ID, amount, order date from orders. Join payment on orders ID and where the payment ID, which is order ID. So where the payment amount which is greater than 2,000, and lastly order by orders date, which is ascending order. So the output will be order ID, amount, and order date, which is in ascending order. Next, this is the question 2. Find the total quantity of bicycles in the inventory for each inventory ID, grouped by inventory ID and sorted in descending order of total quantity. So the SQL code is select inventory ID, sum quantity, as total quantity from Cyclopath Bico inventory, group by inventory ID, and order by total quantity descending. So the output will be inventory ID and the total quantity, which is in descending order. Next, this is the question 3. Find the total amount of the payments made by each customer, grouped by customer ID and sorted in descending order of total amount. So the SQL code is select customer ID, customer name, sum payment amount as total payment from Cyclopath Bico payment, join Cyclopath customer on payment customer ID equal customer ID, group by customer ID, and customer name, and lastly order by total payment descending. So the output will be customer ID, customer name, and total payment, which is in descending order. So the next question is question 4. List all total quantity of bicycles grouped by inventory ID where the total quantity exceed 80, sorted in descending order of quantity. So the SQL code is select inventory ID, sum inventory quantity as total quantity from Cyclopath co dot inventory, group by inventory ID, having sum inventory quantity which is greater than 80, and lastly order by total quantity descending. So the output will be inventory ID and total quantity, which is in descending order. And lastly, this is the question 5. So find all customers who place orders including a service and where the total payment amount exceed 1,800, sorted by customer name. So the SQL code is select customer name, sum payment amount as total payment from Cyclopath co dot orders, join Cyclopath Bico customers on orders customer ID equal customers dot customer ID, join payment on customer ID equal to payment customer ID where orders service is not null, group by customer name, having sum payment amount which is greater than 1,800, and lastly order by customer and customer name ascending. So the output will be customer name, which is in ascending order, and the total payment of each customer.